Today let's discuss about advantages and disadvantages of one-hot encoding. Already we have gone through technical part of one-hot encoding in previous videos. So this video is purely to discuss about advantages and disadvantages of one-hot encoding. But anyway, to give a quick recap, short recap, what is a one-hot encoding? Imagine you have a list of words like these: apples are sweet, bananas are yellow, cherries are red. To work with these words in a machine learning model, we need to convert them into numerical form. One-hot encoding is a method that transforms each unique word into a vector of zeros and ones. For example, if our vocabulary consists of the words as follows: vocabulary, what is vocabulary? Everything are covered in previous videos. Please refer that if you think I'm directly going into this without explaining that. So for example, if our vocabulary consists of these words, right? For this example, apples are sweet, bananas yellow, cherries red. Now if you see, each word is assigned a unique position in a vector. Apples 1, for R 1 is at second position, for sweet 1 is at third position. Only the position corresponding to the word is marked with a number 1, all other positions are 0. Okay, now let's discuss about actual thing, advantages of one-hot encoding. First is simplicity and ease of implementation. It's a straightforward to understand and implement. Python libraries like scikit-learn and pandas provide built-in functions, one-hot encoder and getDummies respectively, that make process effortless. This is a sample to just explain that getDummies and all to perform one-hot encoding from pandas, right? And second advantage is no assumptions about data. It doesn't assume any inherent order or hierarchy among words. Each word is treated as a distinct category, which is useful when the words are nominal and unordered. Now let's discuss about disadvantages of one-hot encoding. First one is high dimensionality. If your vocabulary is large, say 10,000 unique words are there, okay? Each word is represented by a vector of size 10,000, right? If you see here, previous example, we do not have 10,000 unique words. We have only 7 unique words. That's why our vector is having only length of 7. But imagine if that is the situation. That is what I'm discussing in about high dimensionality. Each word is represented by a vector of size 10,000. So this leads to sparse matrices where most elements are 0. Sparse matrices consume a lot of memory and computational resources. Imagine trying to store and process a huge table filled mostly with zeros. It's inefficient and can slow down your computations. The second point is lack of semantic meaning. One-hot encoding doesn't capture relations between words. That is what this means. Words with similar meanings are not recognized as being related. The words, for example, happy and joyful are synonyms, right? But if we take in one-hot encoding, they are represented as follows. Happy is having 1 here and joyful is having 1 at next, even though they are synonyms. So there is nothing to indicate their similarity. And the third issue with one-hot encoding is fixed vocabulary size. The model can only recognize words it was trained on. That's the meaning of this. And if out of vocabulary words are there, they cannot be encoded. Example, if the word grape wasn't in the training data, the model doesn't know how to represent it during testing. That's the main thing. And one-hot encoding fourth disadvantage is variable input lengths. Sentences have different number of words. Machine learning models often require inputs of the same size. The sentence, for example, I like apples has 3 words, while another sentence, You enjoy bananas and oranges has 5 words, right? Their encoded forms have different shapes, making batch processing difficult. And coming another disadvantage is risk of overfitting. This model might memorize the training data and poor generalization to new data. For example, a model might perform exceptionally well on training data but fail to make accurate predictions on unseen sentences because it hasn't learned underlying patterns. So that is what the risk of overfitting. Let's say we are working with these 3 sentences. Robots are fascinating, AI is the future, machines will learn. If we take vocabulary out of it, these are the things, right? Robots are fascinating, AI is the future, machines will learn. Each word will be one hot encoded based on its position in the vocabulary, right? If we say take 2 words, robots and AI. If you see robots has number 1, yeah, at first place AI has number 1 representing in the 4th position of the vector, right? So robots are fascinating results in when encoding as sentences, okay? For sentences, robots are fascinating. That results in 3 vectors because three words are there. And sentence 2 AI is the future results in 4 vectors. Sentence 3 machines will learn results in 3 vectors. So different sentence lengths, the number of vectors per sentence varies. Again, it is like high dimensionality with 10 unique words. Each word vector is of size 10. If you can see the size also. And it doesn't have semantic links, right? Words like AI and machines. AI is here, machines are here. Are related, right? Somewhat, but have completely different vectors using this one hot encoding. So coming to the conclusion, while one hot encoding is a great starting point for converting text data into numerical form, especially for categorical variables with a limited number of categories, it doesn't scale well for large vocabularies in NLP tasks. It ignores the meaning and relationships between words, leading to inefficient models that may not generalize well to new data. So understanding these limitations is crucial for selecting the right encoding method. Depending on the specific requirements of your NLP project, you might explore more advanced techniques that capture semantic meaning and handle large vocabularies more efficiently. Thanks for watching, and I hope this pros and cons, I mean advantages and disadvantages of one hot encoding is very clear for you people. Let's meet again with another new video.